Okay, hello and welcome to part 3 of our mini-series on t-tests. This section is about significance and what do we mean by when we say that we have a significance test, and what sort of assumptions do we have to make about our data so that we can apply these tests. So we have two means. So we can compare these two means on a chart, and the two means look different. So in this case, we've got task completion time and we have system A and system B. But that doesn't necessarily mean that there's a statistical difference between these two groups. And what we have to find out is, could this situation have occurred by chance, given our wider population? So if we assume that we tested students, we tested 40 students, could we replicate this by just going and pulling another random 40 students out of the student body? So what the statistical test will tell us is the extent to which that variance in the mean can be explained by the independent variable, system A or system B, and how much cannot be explained by the independent variable. So it will tell you the probability that those differences might have occurred by chance. So if we have high confidence that there is differences between those two things that can only be caused by the independent variable, now that's assuming that our experimental design is good, then the probability of that occurring by chance is quite low. So we can set a null hypothesis, and the null hypothesis here means there is no difference between the two levels of independent variable. And if we get a significance of less than 0.05, then we're going to reject that null hypothesis and accept our alternative one. Now note that we are not saying that the alternative one is true, but we are accepting it and rejecting the null hypothesis. So hopefully that will make things a little bit clearer. That will become clearer as we explore what that means in terms of a null hypothesis. So if this is our set of possible results, and it's got a nice bell curve shape to it, it's a normal distribution, we know that within that main body of that curve, that's going to be that there is no difference. So if we take a null hypothesis that there is no difference, the most likely observation that we will find, if we had all of the results for our independent variable, and we randomly plucked another number out of our sample, it's most likely that it's going to be in that curve, in that part at the middle, and within the 95% statistical significance threshold. Now that threshold can either be at one end or both ends. In this case, it's at one end, and we have an observed value. So that observed value falls just outside of our 95% significance threshold. Now, if you remember from before, we said that within -2 and +2 standard deviations of the mean, that was going to be 95% of the values. So when it falls outside of that into the realm of these unlikely observations, that is the case at which we will reject the hypothesis. Reject the null hypothesis. So how do we do this? The way that we do this depends on our experimental design, how many variables we have, and so on. So if I've got more than 2 conditions, I need to do an ANOVA, or an analysis of variance. Now, condition is a broader term than you think. So in the case that we discussed the other day, we talked about having one independent variable with 2 levels. So the first level was finger input and the second level was nose input. Imagine I had another one which was elbow input and I had to interact with my phone using my elbow. Now I've got 3 levels, and that's more than 2 conditions. We also had an idea that we would add in screen size. So if that's the case, I now have 2 independent variables with 2 levels, so that's 4 conditions that I can possibly have. So in that case, I'm going to do an analysis of variance. That is beyond what we are going to be doing in the next session, but you get different versions of an ANOVA, and they'll depend on whether you have repeated measures, so the participants doing things over and over again, or whether you have one way, or you are determining, yes, something is probably greater than or less than, and so on. But in a simple test, a simple sense, this is just multiple t-tests that are comparing all of the things at once, because a t-test is comparing 2 conditions. Sorry. So we have one independent variable with 2 levels, nose and finger. So we can either do a paired test or an unpaired test, and that is dependent on whether or not the participants all came from the same group and therefore the data points are paired relative to that participant, or they are unpaired. So it was an entirely different person who has the corresponding data in both conditions. We would, for the experiment we discussed, we are going to do a paired test because we have the same participants doing both conditions. So there are some things that we need to assume. So there are 3 things that we need to make an assumption about in order for our test to be valid and a sensible thing to do. So the first of these is that all the data points need to be independent of each other. And you can think of this a little bit like a confounding variable. So if you've got something that affects only some of the results, then that error or variability might be affected for all of those results within that group. So let's imagine I have 2 experimenters, and one experimenter gives very detailed instructions, and the other one gives poor instructions. So the group that gets better instructions, you might expect to have a better result because they have a better idea of what's going on. And so that's violating that principle because you're going to have a greater variance or error around the mean in your better instruction class than you are in the other one, or vice versa. It's unlikely that they're both going to be the same. So assumption 1, everything should be the same across both groups, across both variables, and that's expressed as the error of all the data points being independent of one another. The second thing that we need to assume is homogeneity of variance. And what this means is that that variance or standard deviation that we now know how to calculate, those need to be identically distributed. And so what that means is, if I have 2 groups, system A, system B, finger input, nose input, whatever they are, the standard deviations need to be comparable. Because what we don't want is one group to have a very small variance around the mean and you get that really tall curve, and the other one a very flat curve with a big standard deviation, because it's not a fair comparison then. So we need to make sure that the variance, or the error in the data variance around the mean, that is identically distributed. The third thing is that those errors should be normally distributed. So if you have something that is normally distributed, that's the middle example, and you have something that has the mean, the median, and the mode is the same, and it's symmetrical around those central values. So there's no skew. If you have a skew, it means that you're slightly flatter on one side of the curve and slightly taller on the other side of the curve. That means you've got a spread between your mean, median, and mode. And if you have that, then it's not considered to be normally distributed, and the statistical tests will not be as effective because they're designed to be conducted on something that's got normal data. Now, if that data is kind of close to normal, or there is an obvious thing that's wrong with it, you can use transformations. So you can do things like using a square root to try and balance out that curve and match it up. There are various tons of rules related to that, but what we will do is we'll assume that we've met that test, and there are lots of tests that you can do to make sure that you have a normal distribution, and they are contained, within all of the kind of SPSS, MATLAB, R. All of these packages will do that test for you, so you don't have to do any maths to make sure that that works. Okay, so that is, in a nutshell, the significance. That should give you some sense of what does it mean when I say that something's significant, in terms of a kind of quite a high level. And in the next video, what we'll do is we will go on to look at a specific example of a t-test.